evaluate. But the good news is, just because, of course, it's a starter problem, the denominators are the same. So we know we're going to keep the denominator the same because the denominator tells us the sizes of the pieces. And it said you got one of those pieces, and we're going to add 4 of those pieces together. Third sizes, which is our denominator. So how many third sizes pieces would that be? Well, 1 plus 4 is 5. And the improper fraction here, of course, cannot be simplified, but you can change it to a mixed number. Some students have said in the past, are like, this isn't simplified until it's a mixed number, which isn't necessarily true because it's just changing the format. You haven't really simplified it, you've just changed the format. But they mean exactly the same thing, 5/3 and 1 2/3. Same thing. Okay, pulling it all together, 214, I notice patterns and can predict future values in the pattern. That's kind of our first part, and then I can use the order of operations with fractions. So order of operations, which we've talked about already, but today it will be with fractions instead of whole numbers. So patterns, I think we've seen this slide before. You can go from right to left, but generally speaking, when we look at patterns, we're looking from left to right. So even though it says you can go from right to left, it can change the operation. Okay. Now, since this part of the module is multiplication and division, we should probably be looking at some form of multiplication or division. But since multiplication and division are really just, well, multiplication at least is a simplified form of addition, you can find patterns of addition as well. It's usually double pattern. That doesn't have to make sense. Anyways, look at the numerator and denominator separately on these, because if you start looking at stuff together, then you can kind of get things mixed up. Now, there may be a relationship between numerators and denominators, but generally speaking, what they're going to do, they'll change the numerator by a certain amount every time, and then the denominator actually will follow a different pattern, changing the amounts every time. So that's why my recommendation is to look at them separately. But again, some students, they may notice a pattern between numerator and denominator, and they're like, oh, okay, I can see a pattern there, which is okay too. Now we're looking at this pattern. Find the next term in the sequence. You can find the next 3, depending on how much work you want to do. But once again, I would look at this and say, I don't really care. Right now, I would just kind of focus on my numerators, the ones right there. Now, I feel pretty comfortable about this pattern. In fact, I like this pattern. It's a very nice pattern because, so yeah, here you could add 0, you can multiply by 1, but I know for sure this next numerator in the sequence will have a numerator of 1. So this one is pretty quick, and we can see this pattern. Nothing ever changes, and we can change values by nothing by either adding by 0 or multiplying by 1. Now, down here at the bottom, those are commas. I was thinking those are footmarks, but I got 1, 2, 4, 8, 16. So we can look at this. Again, addition would work. You can use some form of addition to figure this out, but multiplication will also work. So yes, that is correct. If I were to look at this one, I could see that I would multiply 1 by 2 to get the 2. 2 times 2 is 4. So this is just showing a repeated multiplication of 2 to get to the next term. 8 times 2 is 16. And then 16 times 2 would be this next one right here. Now you can stack and multiply this. I'm just going to do the work real quick here below. So 16 times 2. 6 times 2 is 12. Carry the 1. 2 times 1 is 2, but add the 1 makes that 3. So 1. And then in this denominator here we have 32. Okay. Now again, now that we see this pattern, we have the next term in the sequence. Is it possible we could find the next ones? Yeah, of course we could. You would just continue to keep, let's get rid of this garbage. You would continue to keep the numerators 1, and then you would continue to multiply the denominators by 2. Boom, you got it. Now, like I was saying on that last slide, though, we generally look at this from left to right. But if you looked at this from right to left, you'd say 16 divided by 2 is 8, divided by 2 is 4, and then continue that way. Whatever. Okay, now this one, this one I would say kind of looks a little funky. See if you can find the next term in this sequence, and we'll go over it. So, once again, I'm covering these up. Some students don't have to do that, whatever. It's up to you. So yeah, right here, Now, some students would maybe look for multiplication first. I mean, I don't really know what you're looking for here. But to get from 3 to 7, at least personally, I would not want to use multiplication, because what do we multiply 3 by to get 7? Something ugly. Something ugly. But if I change that to addition, then we can see, and this just would be a counting thing because they're fairly close together. You'd add 4 to 3 to get the 7 right there. Now, once is okay. You need this happen 2 consecutive times in order for it to be a consistent pattern. So 7 plus 4, would that be 11? Yeah, that checks off. So 11 plus 4 then would be 15. Yep, that's good. And so we see once we get to that third one, then it confirms the pattern, which means that once we get to 19 right there, we can add 4 to that, and that will be our new numerator for the next term. So 19, 20, 21, 22, 23. Boom. All right, in the denominator, we look at this one, and again, a quick note. Looking at this number right here makes me not want to use addition, because I don't know what I had to add to 256 to get to 1024. I mean, I can figure it out, but it's rather large, which makes me think that we're probably using multiplication on this one. In fact, even from 64 to 256, I don't want to do that subtraction either to figure out what's being added. So this is where we use multiplication. So it would be, here I would say 4 times something to get 16. So if you know your multiplication tables on this one, then you can figure this one out pretty quick. Hey, 4 times 4 is 16. But if you don't have this memorized, then you have to use fact families, where you would take the 16 and you'd have to divide it by the first 4, and that would tell you what you're going to multiply each term by. And this would work for 16 and 64, and then 64 and 256 and the rest of them. So this means that we should be multiplying by 4 as we go. Now, I'm not going to show all the math here, but 16 times 4 is 64. 64 times 4 is 256. And 256 times 4 is 1024. So we'd have to multiply 1024 by 4 to get this next value, which I'm going to stack and multiply. 1024 times 4. So 4 times 4 is 16, carry the 1. 4 times 2 is 8, but add the 1 makes that 9. 4 times 0 is 0. 4 times 1 is 4. It appears that our new denominator is 4,096. So our overall fraction, 23 4,096, which is a really weird number, but that's what we got. And again, we can see they used a different pattern for the denominator than they did for the numerator, which I would say plan on that. So order of operations, we've seen this already, and PEMDAS is pretty famous, but it can be off because, as we've seen before, sometimes it's division before the multiplication in step 3. Parentheses and exponents, that's pretty consistent, but it's the multiplication, division, and then the addition and subtraction that can throw us off. So remember, you have to read this from left to right. If you see division first on the left, then you have to do division first. And that's where PEMDAS kind of messes people up, because it can be PEDMAS or PEDMSDA, I don't know. But the same thing is going to apply for addition and subtraction, right? So if you see subtraction first on the left, because we're always reading these from left to right, if you see subtraction first on the left, you must do the subtraction first. Even though inside your heart, you're going to want to definitely do the addition. No, you got to do the subtraction if it's first on the left. So be careful as well, because what they'll do is they'll set up these problems, and they'll be like, hey, look at this number, I don't know, 1/2, and they'll do this. They'll say like plus 4/5 times 1/8. So when we see these types of problems, and this is such a common mistake that we see on exams and finals and stuff and quizzes, students are like, all right, 1/2 plus 4/5. Now, that would be nice if there were parentheses around the two, but you can't do this. This one, you can't do this because there's the multiplication there, all right? Now, to kind of reiterate the order of operation, let's change this addition to a division like this. Okay, so here, some students will be like, oh, okay, 4/5 times 1/8 because it's multiplication before division. No, you can't do this one either because the division is first on the left. So if you see division first, you must do 1/2 divided by 4/5 first, and then you can multiply by the 1/8. You have to do that first. So that's two common mistakes that we see on exams, and the problem is pretty much three fractions like that, but it's set up in one of those, something like that. Okay, now again, this goes back to the idea that sometimes we just do things from left to right, no matter what's there. And students will do this. Well, this one's not as common, but they'll do 7/5 minus 1/2 because everything's from left to right. Can't do that because of the parentheses right there. So we got to look at this set of parentheses first, right? If you need to use PEMDAS, just to remember what the operations are, that would be okay, as long as you remember that multiplication and division is from left to right, and then addition and subtraction is from left to right. So even though the subtraction is happening first on the left, we have a set of parentheses which is before that. So I'm going to take this, let's just keep it. I got 1/2 plus 2/5. What I need from that is common denominators, because we have addition right there. And also, I cannot have, I have it, I just don't want to look at it, okay? Because I don't want that, what was it, 7/5. I don't want to worry about that 7/5. So let's just look at 1/2 plus 2/5 and see if we can do that much. So for me, I'm going to take the opposite denominator, multiply it by the numerator and denominator of the other fraction. So the 5 denominator, we're going to multiply into the first fraction, numerator and denominator. So in the numerator, that'd be 5 times 1, which is 5. In the denominator, 5 times 2 is 10. So I can't emphasize this enough. I cannot emphasize it enough. 1/2 has exactly the same value as 5/10, right? All we've done is change the way that looks. Same value, though. We're going to do the same thing with 2/5. We're going to make it have a denominator of 10 by taking the 2 denominator and multiplying it into the denominator and numerator of that second fraction. So of course, 5 times 2 here is 10, but then in the numerator I've got 2 times 2, which is 4. So there's it's coming 4, there we go. And this is addition. Well, if this is addition, which it is, and the denominators match, then I can keep the denominators because that's the same size pieces. That tells us the sizes of the pieces. And I would have to add the numerator. That's how many pieces we have, 5 plus 4. And when I add those together in tenths, 5 plus 4 would be 9/10. But now that I've pretty much simplified completely the set of parentheses. Now I wasn't showing them, but they were there the whole time, like this. But now that I've simplified it into one fraction, I don't necessarily need it. And on the outside, I now need the 7/5 minus the 9/10. And so just to emphasize, we don't really need the set of parentheses. If you want to keep them, that's fine, but I'm going to get rid of them just for convenience sake, I suppose. Well, I've got 7/5 minus 9/10, and if I can get the denominators to match, that would be great. What I notice here is that the 10 denominator is a multiple of the 5 denominator, so I don't need to change the 9/10 right there, or the minus 9/10. All I got to do is take the 7/5 and make it have a denominator of tenths. So how do I make a 5 of 10? Just multiply it by 2. It's the second multiple, but I'd have to multiply the 7 by 2 as well. 7 times 2 is 14. So now I've got 14/10 minus 9/10. And again, we're dealing with the same size pieces in tenths. This is subtraction. I'm going to take 14 of the tenths and subtract 9 of the tenths, which when I do, 14 minus 9 is going to be 5. Okay, now we've taken the original problem, we've now narrowed it down into one fraction at the end here, 5/10. But that's not our actual answer because of the simplification part. So since we need to simplify this, what can we divide 5 and 10 by to simplify it by? To simplify it, that'd be 5. So if I divide these both by 5, I should get a new fraction, but with the same value. 5 divided by 5 is 1, 10 divided by 5 is 2, which actually we saw back here in the red stuff right there. And that's as simplified as I can make it. So on this one, simplify the lowest terms. We do have an exponent on this one. Now there's parentheses as well, but there's nothing to do in the parentheses. It's just 1/4 in a set of parentheses, nothing to do there. But with that exponent then, I'm gonna cover up this garbage and then just work with the 1/4 to the power of 2. Now I'm gonna take this 1/4 to the power of 2, and instead of showing it with an exponent, I'm gonna show it with repeated multiplication. So that'd be 1/4 to the power of 2 means it's multiplied by itself. You'd have 2 of them. Okay, so that's 2 of them, 1/4 and 1/4. Now I'm dealing with fraction multiplication. So in my fraction multiplication in the numerator, I would have 1 times 1. That's what I'll start with, 1 times 1, which is 1. And in the new denominator, 4 times 4 would be 16. Now that simplifies completely the exponent of 2. So now that I have that, let's see what else we had, right? We got plus the 4 times 1/4. Okay, well, that's all the exponents. Is there any multiplication or division? Yeah, there's just a set of multiplication right there. The multiplication sign wasn't showing, but it was there. And I'm going to make it 4/1 so I can do some fraction multiplication on this. So that means that right now I'm not really concerned about the 1/16. So let's just kind of ignore it for now. I guess we can keep the positive there. All right, so fraction multiplication, however you do this, I would want to use cross simplification, but let's say we forgot to do that. So in the numerator, I'd have 4 times 1, which is 4. And in the denominator, 1 times 4 is 4. And this would be 4 divided by 4, and anything divided by itself is 1. Okay, so we still got that plus right there, and now we've got 1/16 plus 1. Now, it would be easy enough to just change this into a mixed number, 1 and 1/16. Boom, we're done. But let's say we didn't notice that either. So if we didn't notice that, then I'd have to make this 1/1. And then I need the denominators to match. So anything's a multiple of 1, which means I can take the 1 denominator and multiply it by 16. But if I do it to the denominator, I've got to do it to the numerator. So this then would be 1/16 plus. In the numerator, 1 times 16 is 16. In the denominator, 1 times 16 is 16. And now I'm adding 16ths to 16ths. So I'm just going to keep the denominator 16ths, adding the two numerators of 1 and 16. So this will produce a new numerator, still in 16ths though. And 1 plus 16 would be 17. 17/16. But once again, if you wanted the mixed number 1 and 1/16, which technically you can get pretty quick from 1 plus a fraction. A whole number plus a fraction should always give you a quick mixed number. There it is. This is the kind of problem I'm talking about where you'll probably see something like this on an assignment or quiz or test. And this is what we don't want you to do. Do not do this, but some students will be like, 4/5 plus 2/5 is 6/5. Right there. And yeah, I'm skipping some work on that. But that's what we don't want you to do. So please do not do that thing. Right? Because by the order of operations, you can't do the addition first in this problem. So is there any parentheses? No, there's no parentheses. So we can skip that. Is there any exponents? Nope, I don't see any. Is there any multiplication or division? Yep, I do have some of that right there. There's some multiplication. Now keep in mind, we have the multiplication right there, but sometimes what they'll do is they'll take the multiplication and instead of showing it, what they will do is they're going to put this in parentheses instead. So say, look at these parentheses right here. And then some students won't notice that the multiplication isn't shown. It's there, you just can't see it. But then they'll make the mistake of saying, well, there is no multiplication. Well, there is, you just can't see it. This one does show it though, so we're going to stick with that. And this will produce a new fraction where all we got to do is multiply numerators and denominators. So numerators, 2 times 2 will be a new numerator of 4. And denominators, 5 times 3 will be a new denominator of 15. So now I have 4/5 plus 4/15. Oh, this one's nice because the denominator 15 is also a multiple of 5. Now, could you use a different denominator like 75? Yeah, by just multiplying the two denominators by each other. But take your time on these, especially at this point, because if you use 75, it's going to make a lot of simplification, and it's going to be with really big numbers. So on this one, I'm going to keep that 4/15 the way that it is. And we'll keep the addition, of course. But I'm going to take the 4/5 and change it into a denominator 15 so that they match. So what do I multiply 5 by to get 15? 3. Yeah. So then I will multiply the numerator by 3 also. 3 times 4 gives me a new numerator of 12. And yep, 3 times 5 forces the denominator to be 15. So now that they match, I'm going to keep the denominator in 15th size pieces. We'll add the two numbers together of 12/15 and 4/15. Okay, well, still dealing in 15ths here. But what's 12 plus 4? 16/15. Now, I'm going to skip the work on this, but if you wanted to change this into a mixed number, you would have 1 and 1/15. Now, why am I skipping the work? Because the assignment will accept this improper fraction, which is okay. And truthfully, I would prefer that students didn't do that extra work if they didn't have to, because I'm really speaking to myself here, but I tend to make mistakes between the 16/15 and the 1 and 1/15, right? And it's usually just something small, and so I can have this correct, but then if I write something incorrect down over here, then minus points, you know, which we don't want to do. All right, this one, yeah, just to start out, order of operations, there is parentheses there. So we have to start with the 1/2 minus 1/6. And again, just to make sure we keep things in order and we don't get that 11/12 mixed up, just cover it. Do you have to cover it? No, but I like to do it just so I can keep track of where I am. And this is subtraction between the two fractions, which means, excuse me, that I need the two denominators to match. But again, these two denominators, the 6 is a multiple of 2, so you could use 12ths if you wanted to, but actually 12ths may be kind of convenient, but I'm not going to do that because it's just less work, I hope. So I can make the 2 denominator a 6 denominator by multiplying it by 3. Just if I do it to the denominator, I must do it to the numerator as well. So 3 times 1 in the numerator is 3. Now we still have the 1 minus 1/6, the minus 1/6 there as well. And now that I've got that, in sixths, we're just taking 3 and then subtracting the 1/6, which in sixths, 3 minus 1 there, 3 minus 1 is 2. So the parentheses, which were there the whole time, so again, if you like to see them, some students like to see them throughout. I'm just kind of waiting till the end to kind of put them in. Doesn't really matter what you do. In the end of the parentheses, you should have 2/6 right there. Now, can that be simplified? Yes, it can. But it doesn't matter if you simplify that because we still got to do some division. So let's say you did simplify that, you should get the same answer. But I'm gonna make an assumption here that maybe you didn't see it, and then you then just divide by the 11/12, like this. Now we're dealing with division now. It's the only operation that we have left, and once you have one operation left, then just do it. Okay, so even though the parentheses were there, I'm going to get rid of them just to make this a little bit cleaner. But what we don't want is division of fractions. What we would like is, instead of division, multiplication. So if we can change that to multiplication, we got to flip the second fraction, the divisor fraction, into 12/11. So now I have 2/6 times 12/11. Give ourselves some more space there. And at this point, you know what? Let's not do that. I'm going to use simplification on this case, cross simplification specifically. And what I'm going to do is I'm going to take the 12 and 6. These are both divisible by 6. So the 12 I would divide by 6. The 6 I would divide by 6 as well. 12 divided by 6 is going to be 2. 6 divided by 6, boom, 1. Now that's as far as I can simplify that, as far as I can see. And so I would like a new fraction, but I'll have to use multiplication now. So 2 times the 2 there would be a new numerator of 4. In the denominator, it's now 1 times 11, which is 11. So the last thing I'm going to do with this is just kind of check, can I simplify 4 11s? I cannot. So it is done. So we got 2 sets of parentheses, and it truthfully does not matter which set of parentheses you start with. I'm going to start with the one on the left just because I tend to go from left to right, kind of as an order of operations kind of thing. So I'm going to work with this 3/4 minus 1/20. This one is good because, again, 20 is a multiple of 4, so I don't need to do anything with the minus 1/20. Now, before I start my work, which I probably should have done already, is I'm going to just cover up everything on the outside of the parentheses because it doesn't matter, all right? All I'm focusing on is this set of parentheses. So the minus the 1/20, yeah, that's just going to stay minus 1/20. There we go. But that means I'd have to multiply the 4 by 5 in order to make that new denominator of 20. But again, if I do it to the denominator, I must do it to the numerator. So 3 times 5 in the numerator is 15. Now I'm looking at 20ths, subtracting 20ths. That's 15 minus 1 of the 20ths. And when I subtract there in 20ths, 15 minus 1 is going to be 14. Now this fraction, 14/20, can be simplified, but again, I'm not really concerned about that right now. What I would like to do is go back to the top and just remember that we still have to divide by this 1/10 minus 1/50, which is also in parentheses. So let's get this other stuff covered up. I don't really care about the division yet either. But this is definitely a set of parentheses, which I also must work with. Now again, if you did this green set of parentheses first, it's still okay. You should get the same answer. But again, I see 50 is a multiple of 10, so I'm just going to keep the minus 1/50 as is. But I will operate on the 1/10 in order to change it into 50ths, some equivalent amount of 50ths. So to do that, I would take the 10 multiplied by 5. So I'd have to take the 1 times 5 as well in the numerator to get 5/50ths. So 5/50ths minus 1/50, we are dealing in just 50ths. And this is going to be subtraction. But it's 5 of the 50ths minus 1 of the 50ths, which now in 50ths, 5 minus 1 is 4. Okay, now we can go back up to the top, in between the 2 sets of parentheses, because, once again, the 4/20 was in parentheses, and same with the 4/50, but we had that division that's in between. Well, since there's only one operation left, I don't really need the parentheses anymore. But, as usual, we don't actually want any division. What I would like to see is multiplication by flipping the second fraction, the divisor. Now that's, instead of being 4/50, it's now 50/4. So now it's showing as 14/20 times 50/4. Okay, now you can't cross simplify. Let's do straight multiplication. So in multiplication, this will give us new numerators and denominators. I'm going to start with the denominator actually, just because it's going to be a little bit easier. Really, it's 2 times 4, which is 8, and then tack a 0 on. Now you can do 20 times 4 if you'd like, but you're still going to get 80. And 14 times 50, well, same idea with this one. I'm going to take the 0 from the 50 and just tack it onto the product. And then all I've got to do for my work is just do 14 times 5. So 5 times 4 is 20, carry the 2. 5 times 1 is 5, but add the 2 makes that 7. So it's 70, but then we tack that onto the 0. Now it's 780ths. Okay, so to simplify this, what we've learned in the past is that if you see zeros on the tail end of two values like this, you can pretty much just make those a phantom 1. And then I'm just left with, instead of 780ths, I'm now left with 78ths. And again, however you show this work at this point really doesn't matter. Pretty much once we get to here, there's several different directions you can go. This is just one direction. So 70 and 8, well, they're at least divisible by 2. Let's see what happens when we divide these both by 2. So, as usual, I'm going to start with the easier of the two, and that would be 8 divided by 2, which is 4. But I'll have to show some work before 70 divided by 2. And yeah, if you have some kind of shortcut for this or know how to do it fairly quick, that's okay. But I've got 70 divided by 2. So 2 will go into 7 3 times. 3 times 2 is 6 minus, got 1 10 left over, drop the 0 to make it a full 10. 2 goes into 10 5 times exactly. Minus 10, you have a remainder of 0. So that quotient, 35, is our new numerator. And can that be simplified any further? No, it cannot. Again, if you wanted to change the format, you could. Not that you have to. But if you did, you'd get 8 3/4. Again, I'm not recommending that you do that, but you could. So either one of these would work as our answer. There's 214. Pulling it all together, and again, the first part which we saw, you got to notice patterns, and again, usually they'll have kind of a different pattern for numerators and denominators. But then we have to be able to perform order of operations now with fractions, but like we saw in one of those examples, not all of them will be fractions. Sometimes they'll have some whole values in there too.